First of all, the graph equation is given y equals to 3x. Identification of coordinates, that's what you need to do as first. When x is -1, what would be the y value? From our graph equation, we can identify the corresponding y value. Y should be 3 times of x. So 3 times of, in this location, x value is -1. Instead of x, you should substitute -1. 3 times of -1, it would be -3. Next time, next coordinate, when x is 0, y would be 3 times of 0. 3 into 0, it will be 0 again. When x is +1, y would be 3 times of +1. That means y coordinate would be +3. Let's mark our coordinates. When x is -1, y is -3. This is our first coordinate. Second coordinate, 0, 0. Third coordinate, x is +1, y is +3. Now let's plan and execute, do the execution of graph formation. In x-axis, the minimum value we need, that was -1. The maximum value we need, that is +1. So in x-axis, it is totally enough to plan -1, 0 and 1, +1. This is totally enough to maintain in our x-axis. In y-axis, the minimum value we need was -3. Amongst these three, what would be the minimum? What would be the maximum? That's what you should interpret. -3 and +3. So in x-axis, -1 to +1 is enough. But in y-axis, you have to extend a little. Starting from -3. That means below here -3, -2, -1, +1, +2, and +3. This would be our y-axis. Okay, that's all about planning and execution of axis. It is -1 and here +1. Now let's mark our coordinates. That is the one and only thing we have to do hereafter. X is -1, y is -3. So this would be the coordinate. X is 0, y is 0. This origin point. X is 1, y is +3. Okay, this would be the coordinate. After marking the coordinates, you can use your straight line ruler to produce the graph. Okay, that's all about our graph formation. What is the name of this graph? In one of the edge, you should write y equals to 3x. That's all about the formation of y equals to 3x straight line. First, from the graph equation, identify the coordinates. Then plan and execute the graph axis formation. Plot your coordinates and draw the straight line graph. That's all. Next graph equation, y is -2x. I will explain the first one. Y is -2 times of x. No. So -2 times of x. And -2 is the coefficient. In this occasion, x value also -2. So -2 multiplied with another -2, that will produce y coordinate as +4. It is not just 2, it is -2. No, -2 into -2, it would be +4. In second case, -2x. So -2 times the x value in second occasion is -1. -2 times -1, it would be +2. That would be the coordinate. Likewise, you have to find all the coordinates. So other coordinates would be, when we substitute 0 here, -2 times 0, it will become 0. -2 times 1, -2, and -4. Then the coordinates, -2, +4. It's not compulsory to indicate positive direction. -2 and 2, 0, 0, and 1, -2, and thereafter 2, -4. Now let's plan our axis. Okay, in x-axis, the minimum value we need was -2, maximum value is +2. In y-axis, minimum value -4, maximum value +4. Okay, the planning is over. Then execution. X-axis -2 to +2. -2, -1, 0, +1, and +2. This would be our x-axis. And next one is y-axis. So the minimum is -4. So -1, -2, -3, and -4. Positive region, we will have +1, +2, +3, and +4 as maximum. This would be our y-axis. Labeling of axis, that is important. Let's mark our coordinates. First coordinate is -2, 4. X is -2, y is 4. Okay, this would be our first coordinate, -2, 4. And x is -1, y is 2. Next coordinate would be this. Next, usually 0, 0. X is 1, y is -2. X is 2, y is -4. Then we can connect them. Okay, this would be our graph. Its name is y equals to -2. Okay, then next one, in the same Cartesian plane, just keep this one as it is. In the same one, we are going to plot one more graph, that is y equals to -x. Next graph, y equals to -x. Here I'll give you the x coordinates as -2, -1, 0, 1, 2. What you should do is you should identify their corresponding y coordinates. What is the value? Y is -x. That means the coefficient would be -1. Okay, -x means -1x. You have to keep it as -1x. Then identify the y coordinates and write both x and y coordinates here inside the brackets, and in the same Cartesian coordinate plane. No need to plan another graph. In the same graph, you have to mark the corresponding coordinates and draw one more graph. Okay, somewhere here or here that will come. So we are going to compare both graphs in the same Cartesian plane. That's what we are going to do hereafter. What you should do is find the y coordinates and mark them to create your graph. So next one, y is -1x. So y is -1 times of x, -1 times of, here the corresponding x value is -2. So -1 multiplied with -2, that will give you +2. Next case, -1 times -1. Negative into negative, +1. -1 times 0. It would be 0. -1 times that -1 is existingly in the equation. We cannot change that, but these discrete variables, that's why in all locations the x values are only changing. The other one doesn't change. +1. -1 into +1, it is -1. -1 into +2, it is -2. Let's write the coordinates in order. First x coordinate -2, y coordinate 2, x coordinate -1, y coordinate 1, x coordinate 0, y coordinate also 0, x coordinate 1, y coordinate -1, x coordinate 2, y coordinate -2. Okay, that's all. Let's mark these coordinates in our Cartesian plane. Then x is -2, y 2. X is -2, y is 2. This is our first coordinate. X is -1, y is 1. Next coordinate. And x is 0, y is 0. X is 1, y is -1. It is opposite. X is 1, y is -1. X is 2, y is -2. Oh, that's all. We can connect them by using our straight line. I think there's a small deviation here. Okay, so this graph's name y equals to -1x. -1x. this one. The orange color one is representing y is equal to negative 1x graph, and other one is showing, the previous one is showing y is equal to negative 2x graph. So look at this. If the gradient value is changing, no matter what, that is positive or negative, look at this. If the gradient value is changing, the slope is increasing. The slope is increasing. We have to measure the slope from the negative axis. Okay, negative region of x-axis. Just keep it as a stable. If it is, if the gradient, the number is located before the x, it is called as gradient or slope of the axis. There are two names. One is gradient, or else we are using the name slope, slope of the axis. Okay. If the gradient is negative 1, look at this, the slope is little deeper. If the gradient is negative 2, look at this blue color straight line. If the gradient is negative 2, this inclination is increased, the slope is increased. So that's why if the gradient is increasing, we are not bothering about negative or positive, we are just concerning about the value. If the gradient is negative 1 in x, from x-axis negative point, the graph slope is little deeper. If the value is 2, it is little greater than that. Think about it. If we draw in the same axis, if we draw one more graph for y equals to negative 3x, that would be like this. Okay, that will come something like this, because the angle should increase. Angle should increase. Here the gradient is 1, so angle is low. Gradient is 2, angle is little intermediate. If the gradient is 3, angle will increase. If the gradient is 10, gradient is 100. Likewise, in all occasions, the inclination, that means the angle with respect to axis, that is changing. So do not worry about it. What you should remember is, you should remember, when we change the gradient, same graph doesn't exist again as well. Even though we use the same Cartesian plane, look at the coordinates. When the coordinates are changing, the graph also exactly changing. That's what you have to take it as a conclusion from this graph. I will explain that again. This is y equals to negative 2x, y equals to negative 1x. Same axis, same x values. Okay, we use same x values, same Cartesian plane, but the y coordinates were changed. Now, according to the change of y coordinates, we just produced two different individual graphs for our calculations. That's what you should understand from here.